Hi, my name is Appu. So I'm CEO and Chief Scientist of Mobis Labs. So I've been always been fascinated with computer vision. I've been doing building computer vision algorithms for the last 25 years of my life. Did a PhD and postdoc in that, and formed Mobis Labs roughly 3 years back. And for me, it's really a super exciting time to do really fundamental things in computer vision, because if you remember, if I sort of recollect, maybe 15, 20 years back, to build a very rudimentary sort of classifier, say you want to do an OCR application, it took us around 6 to 7 months of hard work, and it worked in very limited use case. But now the technology is working seamlessly in different applications. And that's what we are doing. We are enabling enterprises to not to have this large grind, but just use the software that we are developing and actually put it in their applications and give these applications power of sight. To give a small introduction about Mobis Labs, we are a Berlin-based company in Germany. We are a fun-loving set of geeks who are really passionate on figuring out how to make machines see, and also providing value, the value that it unlocks when you give machines the ability to see to various enterprise clients. And in generally, it's an exciting time because a lot of applications are getting built using visual AI. For example, media companies are building tools like, say, visual search or recommendation engine. And computer vision, especially visual AI, is playing an important part in powering these applications. And what we do as a company in Mobis Labs is we give a piece of software which allows enterprises who wants to build or who already have such services to supercharge this with AI with very little investment on their side. Or if you take about some other kind of imagery, say technical imagery, satellite imageries, which are the most valuable and most expensive images to keep. But why these images are valuable? Because that tells a lot about what is inside the data. You can maybe identify wildfires, you can track some activity which is happening in the port, etc. And all of these things, when machines have the power of sight, is able to sort of do it automatically, and we are able to empower these organizations with that. Last but not the least, our algorithms are super fast and efficient, so we can put it in various form factors like mobile phones, Raspberry Pis, edge devices, and even now we are having projects to put our technology directly into sort of onboard satellites, for example. So what we provide as a company is a product which is an SDK, and on top of that we have a no-code training interface, which is one of my favorite part of our feature set, which allows not only data scientists but maybe someone who is new to the field of computer science generally to sort of not only use computer vision solutions but also to train computer vision solutions. Our solutions are available as an on-device and on-prem installations, on-device and on-prem installations, and we will have Linux, Windows, and OS X installations coming soon. It's almost always installed locally, so it works standalone. When you use Mobis Labs solution, you don't need a network connection. And we also have spent a lot of our working hours optimizing the quality. So we have some of the best image and video recognition quality solutions embedded into our SDK. And also we spend a lot of time in making our models pretty lean, efficient. So it's really optimized for maximum speed. And also, as we really care about the privacy of users, so we also make a promise to all our clients that we never see their data. So let me give an example of how it works. So one of the applications that we power across multiple organizations is visual search. So here I'm going to show you a demo of how our technology sort of powers visual search. So this is an application where I'm going to search over 2 million unsplashed images. None of these images have any metadata attached to it. Our computer vision algorithms have gone through this data, understood what is inside this, and that is what is essentially powering the search. We also connect NLP, means natural language, with computer vision models so that you can actually search in very free-form text. For example, we work with a lot of journalism companies. For them, for example, it's important to find images which represent, say, a woman getting vaccinated. And this is what the algorithms automatically picks up. It's understanding it's a woman, it's understanding that action is vaccinating. Maybe let's try another query, a model wearing Adidas. Here you can see that the machine learning algorithms were able to understand this was a brand, Adidas, and it has to be worn by a model. Let's do something funny. Let's chicken crossing the road, for example. Again, this was completely untagged 2 million images, and machine learning algorithms was able to go and find that particular chicken, which was indeed crossing the road. And it works with videos also. Here is also the same application where instead of doing image search, we are doing video search. And let's say you want to find a particular thing. So there is 28,000 YouTube trailers that we're searching over. That's over 500,000 minutes of video. In that video, can you find some frames, which is very good, which can represent impact of climate change, so you can tell a story. So here you can see the variety of video segments, snippets that's able to take it out. Or maybe you want to find a particular your favorite actor. Meg Ryan was one of my favorite actors growing up, so you can find her pictures maybe in one trailer. I think the first one is You Got Mail or something like that. And this is something like when you install a mobile solution and you're sitting all over this download of archive, suddenly your archive becomes completely supercharged because machine learning algorithms that we provide is able to pick up these subtle and very wide variety of aspects. But another thing which is very super interesting for us is that if you as a company and you want to sort of teach the machine to learn something new, for example, and we have this interface where you don't need, it's not a programmatic interface, it's designed for product managers or non-technical users to train their own models. So I want to find rotten oranges. All you have to do is go and upload few positive set of images, around 79 positive set. And if you want, as an optional step, you can also give some negative images, for example, healthy things. And I have uploaded some validation. And now I'm training the model. So what will happen is the model is going to train. The validation set images I uploaded are images that the model has not seen, and it will give it a score between 0 to 1. 1 means that's very highly probable that these are rotten oranges, and 0 means that these are not rotten fruits. So you can see this is initial results that you see. So it's doing a very good job, essentially picking out rotten fruits from the others. But maybe you want to get a bit more specific. You want to say, okay, you might have seen some images of, say, rotten bananas, but you want to concentrate your attention only on to one particular kind of class. Then you can actually fine-tune the model by using using the UI, saying, okay, I think that probably is an apple. Like you don't want to see something, and you can retrain the models just to correct for the things. And now it is going to a new test set with this improved model, and you can do this process over and over and again till you are satisfied, and then you can see the results on the test set, and you will see how the new updated algorithm is essentially scoring the test set. So roughly, I think there is around 200, 300 images in the test set. Now you can see that it's trained a very good rotten orange classifiers and spitting out all the rotten oranges. Just a little bit, since it's a small talk, I'm only going into the technical aspects of this a little bit, only in not in full details, but more in a sort of a top level view. So what we as a company, especially our science team inside the company, that we do is we build algorithms with two goals in mind. First of all, these algorithms, machine learning models, most of them are either convolutional neural networks or transformer-based models. This has to be super efficient so that you can run inference and even training with very low cost. and it should be also have the capability to do few shot learning. So that means that it should have the ability to learn new concepts with relatively less amount of training data. And the trick for us, or the consideration for this, is to build very rich feature representations, which are both conducive for both few shot learning and both being an efficient algorithms. And I will just summarize sort of our daily work life, especially for the science team, is we essentially work on three things. On data, we have various deep questions to ask about the data, what kind of data that we should train, and how should we sample the data while we train these algorithms. On the algorithms itself, how do we pose the problems, essentially, what specifically are we looking for in a good feature representation, and last but not least, on the efficiency of these algorithms. So we're constantly asking questions here. There are no easy answers, but that's what makes the scientific process fun. And maybe a couple of things that we discovered on the way is from the data side is that like doing end-to-end, instead of doing end-to-end fully supervised learning, training on noisy data sets where there is a sufficient amount of label noise, but maybe a large set, usually build up very robust feature detectors. And from the algorithm side, while we learn, one thing especially which is good to model while these algorithms are learning is transferability. And last but not the least, on the efficiency side, one of our key observations that we have stumbled upon is that inference usually requires less network capacity than training. So models like distillation approaches, etc., where you can have a way that you train in something, then transfer that into a smaller model, works really good. But again, there is always a lot more interesting problems coming in, so it makes our work life both very interesting. And let me maybe end with this particular sort of picture, because I grew up reading a lot of sci-fi books, and for example, Isaac Asimov's books, everything. And you see that there are these robots who's navigating the visual world, doing automated tasks and doing a lot of applications. And this is our dream with Mobius. We are making it easy for anyone to sort of build application using our technology. And this is a really exciting journey. So really looking forward for your questions and feedback. And you can also reach out to me in this particular email address.